Hey pre-calc, all right, we are now moving on to chapter 7. So congratulations, you guys survived chapter 6, okay? So we are starting with 7.1, the inverse sine, cosine, and the inverse of tangent functions. So we are going to review a little bit. Remember, to have an inverse, f inverse composed with the regulated function f of x must be x, okay? For every x in the domain of f and the reverse order, f composed with f inverse of x must also be x for every x in the domain of the inverse. So what we're saying is that f composed with f inverse should be identical to f inverse composed with f of x, and they should come out to be x, okay? For us to have, for them to be inverses of each other. The domain, if you guys remember, the domain of the regular function, okay, is the range of the inverse because we are switching, okay, x and y values. Switching x and y, okay? Then that means the range of the regular is the domain of the inverse. Because the composition comes out to be x, the graph of the normal and the inverse are symmetrical about this line, y equals x, okay? And that is the identity line. Because this line right here is the identity line. If a function y equals f of x, we are number 4. Okay, so if a function, so whatever this function is, if it has an inverse, the equation of the inverse function is switching x and y. So this right here is switching x and y, okay? Notice how now y is the input and x is the output. That's what it means by switch x and y. And then you have to solve for y. So the solution means solve for y, okay? When you solve for y, y is now equal to the inverse of an input x, okay? So in short, if this right here, if a function has an inverse, okay, you need to switch x and y. And then solve for y. Okay. Let's go back and quickly graph out sine. Okay, sine has a period of 2 pi. So I'm just going to go a period to the right and another one to the left. So each period has 4 equal intervals here. So I'm going to go in and mark 4 equal intervals. Sine goes up as high as 1, as low as -1. So sine at 0 is 0. Sine at pi over 2 is 1. Sine at pi is 0. Sine at 3 pi over 2 is -1, and 2 pi is back to 0. So here's a full cycle on the right. And then we are going to repeat the pattern. We are now completing a left cycle. Okay, so here's what I have here is 2 full cycle, okay? So first is y, I'm reading this with you, is y equals sine a 1-to-1. Keep in mind, if I can remind you what a 1-to-1 is. 1-to-1 is when the function passes a horizontal line test, okay? A horizontal line test goes like this. Whee! Okay? What does it mean by passing it? It means it cannot intersect more than 1 time. It can intersect 1 time or no times, but the moment it intersects more than once, then it's no longer a function. So if you look at this, this is my horizontal line, and it's intersecting right now, as I can see, 4 times. So this right here is not a 1-to-1. Okay. Now I need to erase, because you don't need to erase, you can keep it on there. All right, because it doesn't pass the horizontal line test, I need to go and ask myself the next question. Let me go back and mark this. Okay, question number 2. Because your answer is no, we have to restrict its domain so it can be a 1, 2, 1. Okay, because I need it to be a 1-to-1 function to start with. So when you take an inverse, it can also be a function. So universally, we have decided to, I'm going to make a few different marks here. Question number 1, universally, can I cut this? Let's start here, okay? Because I know that starting at 0 is always the easiest. Can I chop it off from here to here? Is that a 1-to-1? Okay, keep in mind, it needs to pass the horizontal line test. So is that a 1-to-1? No, that is not a 1-to-1. So let's go chop it up somewhere else, okay? Erase what I have marked. So I'm going to say, hey, you know what? From 0 to pi is not a good idea because it's still not a 1-to-1. How about if I go and cut it off, okay, cut it off from 0 to pi? Is that a 1-to-1? Let's draw a horizontal line test. Nope, it's still intersecting 2 times. So that's still not going to work, okay? So now we are going to erase that. How about if I cut it off from 0 to pi over 2? Okay, well that will work, but that's kind of short, isn't it? So what we do as mathematician is that, hey, we can cut this off in a lot of different places, okay? But easiest is to include the 0 in it. So what we do is we cut it off from negative pi over 2 to pi over 2, inclusive. So here, if I cut it off from negative pi over 2 to pi over 2, this is the only piece of sine that I can take with me, because when I find its inverse, it's still a function, okay? So look, when I draw a horizontal line test, it's not intersecting more than 1. It intersects exactly 1 time. So that's why all of the mathematicians, we come together and be like, you know what? Let's just agree on taking from negative pi over 2 to pi over 2. So inclusively, we are now cutting off or restrict its domain from negative pi over 2 to pi over 2. And let me show you what quadrants, okay? Negative pi over 2 is this way. So you're in quadrant 4. We're taking quadrant 4. And pi over 2 is this way. So we are taking quadrant 1. So keep in mind that sine, okay, on the graph, we are taking from negative pi to pi. Here is the value. But on the coordinate plane, you can think of it as quad 1 and quad 4. Now, let's write the definition of sine inverse, okay? Sine inverse, we are going to start with, we're going to switch x and y. So x equals sine of y, okay? But we do have to, if keep in mind, we have to solve for what? Y. So to solve for y is now, we're going to use f inverse to denote our inverse function. So now we're going to say, hey, I'm going to compose sine inverse to both sides. So this is our definition of sine inverse. So again, so sine inverse is when you are switching x and y. Then you have to go and solve for y. Let's state the domain and range for sine inverse, okay? The domain of sine inverse, keep in mind that is the range for our normal. The range for the normal, if you remember, was from negative 1 to 1. From the range of the inverse, okay? The range for the inverse is normally the domain of the original. But remember, to have an inverse function, you have to restrict it. So this range is restricted from just negative pi inclusive over 2 to positive pi over 2. Okay, so this right here, it's super important. These right here are so important that you're going to need to know. So what we're going to do now is we are going to graph out sine inverse, okay? But before we graph out sine inverse, I want to start with sine. Y equals sine of x with restricted from negative pi over 2 to pi over 2 only, okay? So here's where I'm going to be positive pi over 2 and negative pi over 2. And I'm going to go up and do positive pi over 2. And yes, you can label y and x's using pi as well. Pi over 2 is about 3 over 2. Okay, so I'm going to make a 1 mark this distance. 1 mark this distance. 1 and negative 1. Okay. All right, so what we are going to do is I'm going to look at this. See this right here? This is a negative pi over 2 comma negative 1. So that's what I'm going to use, okay, for my regular sign in blue. Negative pi over 2, negative 1. Ooh, there's my dot, okay. This dot is 0, 0, so that's what I'm using. And this dot over here, as you can tell, positive pi over 2, comma positive 1. So positive pi over 2. So here's the regular function for sine. I'm going to label this f of x. Then I would do sine inverse, y equals, in green. Okay. Let's label the points again. Okay, so this is pi over 2 comma 1. This is 0 comma 0. This is negative pi over 2 comma negative 1. Now, when I'm graphing sine inverse, all I do is I'm going to switch x and y. So this point right here, okay, switching x and y, meaning that now I would have a 1 comma a positive pi over 2. Okay. We have done inverses already, so this is not anything new to us. When I switch 0, 0, I still have 0, 0. But when I switch negative pi over 2 comma negative 1, I now have a negative 1 comma negative pi over 2. So negative 1 comma negative pi over 2. So these are the points I'm switching. Now notice how I'm hugging. See this, my normal f of x, okay, which is restricted domain. I'm hugging the x-axis, meaning the inverse is now hugging the y-axis, okay. Similarly, see how this blue one, which is my normal f of x, my regular function, is hugging the negative x-axis. Then the y function is now hugging the inverse is now hugging the y-axis. Now, if you can you see that there's a symmetry of this line? Okay, what does that mean? That means, hey, is it reflected over the line y equals x? Okay, I'm drawing by hand, so as you can see that it's the best I can do without any calculator or graphing utility. But if you just eyeball this, okay, it should be symmetrical about the line y equals x. Okay, all right, so this is the end of our sine inverse function. Tomorrow we will do cosine. So let me give you a joke for today. This is what my chiplet told me the other day. What did one flower say to another flower? What did one flower say to another flower? What did one flower say to another flower? Hey, bud. That's it. Have a wonderful day.